Welcome children. Now we are going to discuss about heating effect of electric current. Before we are going to discuss about this heating effect of electric current, let us look at our previous class, the things we discussed about different ways in which we can connect resistors. Among that, one is a series connection. When we connect resistors in series, the total resistance in the circuit or effective resistance in the circuit R is equal to how much? R1 plus R2 plus R3 etc. That means total resistance here will increase. But when we connect resistors in parallel, when the resistors are connected in parallel, it's a total resistance or effective resistance we can find from the relation 1 by R. Here R is the total resistance in the circuit when number of resistors are connected in parallel, and we can obtain it from 1 by R1 plus 1 by R2 plus 1 by R3. This way we can find out. Here total resistance in the circuit reduced or decrease, or here the total resistance is smaller than the smallest resistor connected in the circuit. With these two relations we want to solve some problems that is here given in our text. Among that, first one, judge the equivalent resistance when the following are connected in parallel. Judge the equivalent resistance when the following are connected in parallel. Here are some resistors. First one A, then is 1 ohm and 10 raised to 6 ohm. These are connected in parallel. We want to find out equivalent resistance of these two. See, we know when the resistors are connected in parallel, 1 by R is equal to 1 by R1 plus 1 by R2. Here, this R1, we can take as the first resistance 1 ohm, and R2, the second resistance 10 raised to 6 ohm. So, 1 by R is equal to 1 by, here first resistance is 1 plus 1 by 10 raised to 6. Now again 1 by R is equal to, we can cross multiply 10 raised to 6 plus 1 divided by this product 1 into 10 raised to 6. Now again 1 by R is equal to this 10 raised to 6 plus 1 into 10 to the power 6 plus 1 divided by 10 raised to 6. We can take a reciprocal here. That is R is equal to 10 to the power 6 divided by 10 raised to 6 plus 1. See, when the value of 1 is added to this 10 raised to 6, that does not change much. Hence, when we divide this 10 raised to 6 with this 10 raised to 6 plus 1, its value is nearly, both of these quantities nearly equal. So, we can take here the value of R approximately 1. That means effective resistance is in the circuit now is 1 ohm. Effective resistance in the circuit now is 1 ohm because these two quantities nearly equal. Now another question, that is B from the first one. See, B, that is here given 1 ohm, 10 raised to 3 ohm, and 10 raised to 6 ohm. These are connected in parallel. Now see, its effective resistance, that means 1 by R is equal to 1 by first resistance 1 by R1, that is 1 plus second resistance is 1 by R2, that is here R2 is 10 to the power 6, so 10 raised to 6 plus third resistance, that is 1 by R3, that is here 10 to the power 6. Once again, we know 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Here R1 is 1 ohm, R2 is 10 raised to 3 ohm, and R3 is 10 to the power 6 ohm. We put the values of R1, R2 and R3 in the equation. 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. When we take the LCM of these all, we get LCM as how much 1 by R is equal to, here we get LCM of these are 10 to the power 6. Then each quantity we want to multiply with this LCM, that is 1 by 1 into 10 raised to 6 here, 10 to the power 6 plus again 1 by 10 to the power 3 into 10 raised to 6, how much will come? 10 to the power 3 and 10 to the power 3 cancel, then the remaining 10 raised to 3. Then here it will 1 by 10 raised to 6 into LCM, 10 raised to 6, its value is 1. So again 1 by R is equal to 10 raised to 6 means with 6 0, 4, 5, 6 plus here 3 0 and 1 divided by this. 10 to the power 6 means 1 with 6 zeros. Now we can add this all. 1, 2, 3, 4, 5, 6 0, and here with a 4 and here 1. That is 1 0 0 1. This is the value we get by adding this on. So 1 by R is equal to, again 1 by R is equal to the value of this all 1, then by see, then R is equal to when we divide this with this all, we get the value is equal to 0.99. We get the value as 0.999, etc. That means if we want to take, we can take this also approximately 1. That means here also we get the value nearly equal to 1, or here we got the value R is equal to, how much it will get? 0.99, that much. That means effective resistance, its unit is ohm. Effective resistance, unit of resistance is ohm. See, here we connected number of resistance What is the effective resistance? Here the smallest resistance is 1 ohm, but the total resistance in the circuit is now less than 1 ohm. How much it will be? 0.99 ohms. Now, let us go to the next question. Which is given in our text. And third question, what are the advantages of connecting electrical devices in parallel with the battery instead of connecting them in series? What are the advantages or what are the merits of connecting electrical devices in parallel with the battery instead of connecting them in series? That means when we connect electrical devices in parallel with the battery, there are certain advantages or merit. We want to know which are the merits of this connection. Among that one is here each appliance get a same voltage. That means when we connected appliance which is parallel to the or parallel with the battery, we get each gadgets or appliance with the same voltage. That is the voltage we apply. Then current through them not the same. That means current that means branches out. That means current in each appliance different. That means each appliance works its own power by drawing the amount of current. Then third one is the effective resistance. That means we can reduce total resistance in the circuit. We can reduce the resistance in the circuit by connecting appliance or devices parallel to the battery. Then we can control each of them, or which appliance we want to work, that only we can work, others we can off. These are the advantages of connecting appliance parallel to a battery. Which are the advantages? Each of them will get the same voltage, or each of them works under the same voltage, and a different current according to the needs of the device. It will get the current. Then total resistance in the circuit reduced or become smaller than the smallest resistance that we connected in the circuit. Then if we connected in series, then what is the problem? We cannot get appropriate voltage for each of them. That means voltage different. Then current through all the appliance will remain the same. So to work each appliance its own power, it required different current, but by connecting in series, that appliance does not get the required current, and also total resistance there will increase. These are the disadvantages of connecting them in series. Now another question here given, the fourth one, how can three resistors of 2 ohm, 3 ohm and 6 ohm be connected to give a total resistance of 4 ohm and be 1 ohm? Here three resistors given. First resistor and its resistance R1 is equal to 2 ohm. Second resistor and its resistance R2 is equal to 3 ohm. And third resistor, it is R3 of resistance. That is resistance is given as 6 ohm. Now question we want to find how or in which method by connecting we get a total resistance of 4 ohm in the circuit, then also to get 1 ohm in the circuit. These are the things we want to find. See, to get a 4 ohm in the circuit, which is the method? We can connect these resistors. Here 2 ohm, 3 ohm and 6 ohm. See, first of all we are going to connect this 3 ohm and 6 ohm resistance in parallel, then to it 2 ohm resistance is connected in series. Now we can calculate what is the total resistance in the circuit. How much is the total resistance now in the circuit? See, by connecting these 3 and 6 parallel, we know 1 by R is equal to how much? 1 by R1 plus 1 by R2. That is 1 by R is equal to again 1 by R1. How much it will be? 3 ohm and 1 by R2. It is 6 ohm. Again 1 by R is equal to, we can cross multiply this 6 plus unit we can write later on, and this 3 divided by 3 into 6. Again 1 by R is equal to 6 plus 3 9 by 3 into 6 18. Now taking reciprocal, so R is equal to 18 by 9, that is equal to 2 ohm. That is, by connecting these two in parallel, the resistance of these two in the circuit is only 2 ohm. Added to this 2 ohm, we connected another 2 ohm resistance. So now this is in series with these two are in series with this one. So the effective resistance R is equal to R1 plus R2. R1 plus R2. We can take this one as R1. That means effective resistance of these two. Effective resistance, we know what is R is equal to R1 plus R2. So effective resistance of these two is how much? 2 ohm. Plus another we connected series R2, that is also 2 ohm. Total how much it will be? That is altogether 4 ohm. We got a 4 ohm. First question's answer is 4 ohm. Here also we got 4 ohm. How we got two resistors of resistance 3 ohm and 6 ohm. That two are connected parallel. Then that combination is connected in series with the 2. Here we got how much? 4 ohm resistance. Now we want to find out how we can get a resistance of 1 ohm in the circuit. How we can get a resistance of 1 ohm in the circuit. Now to get a effective resistance of 1 ohm, we can connect the given 3 resistors. First one is with the 2 ohm, second one is with the 3 ohm, and third one is with the 6 ohm in parallel. Now we can calculate the effective resistance of these 3 resistors that are connected in parallel. That is 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. That is 1 by R again is equal to 1 by 2 plus 1 by 3 plus 1 by 6. Now LCM of 2, 3 and 6 is 6. So 1 by R is equal to R is the LCM. 6 is the here R. We can find out by taking LCM of these 3 and then adding. That is 6 here we got as a LCM. Now with 1 by 2 into 6 we get 3. 1 by 3 into LCM 6 we get 2. 1 by 6 into LCM 6 we got 1. That is 1 by R is equal to 3 plus 2 5 plus 1 6 by 6 that we can get as 1. So R by taking reciprocal 6 by 6 how much it will be? 1 ohm. So we got answer to the second question. That is here effective resistance or total resistance R is 1 ohm. Now we got answer for first and second question. Here 3 resistors connected in parallel. Now another question here given is what is the highest and lowest total resistance that can be secured by connecting by the combination of 4 coils of resistors of resistance 4 ohm, then 8 ohm, then 12 ohm and 24 ohm. Here we want to find out what is the highest and also lowest total resistance that can be obtained by the combination of these 4 resistors. See, at first to increase the resistance in the circuit, we know the resistors must be connected in series. Here first resistance R1 4 ohm. Second resistance R2 it is 8 ohm. Third resistance R3 12 ohm. And this one is with the R4. This is equal to 24 ohm. Now we can connect these resistors in series to get maximum resistance, that is R is equal to R1 plus R2 plus R3 plus R4. That is R is equal to R1 plus R2 plus R3 plus R4. That is equal to 4 plus 8 plus 12 plus 24. How much it will be? We know this 12 plus 8 20 plus 4 24. 24 plus 24, how much it will be? 48 ohm. This is the maximum resistance when they are connected in series. That is 4 plus 8 12, 12 plus 12 24, 24 plus 24 48 ohm. Now we want to find out least resistance in the circuit. See, to get least resistance, we want to connect resistances in which manner? That means we want to connect the given resistors in parallel. That means 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4. Here 1 by R is equal to 1 by 4 first resistance, 1 by R2 1 by 8 plus 1 by R3 that is 12 plus 1 by R4, how much it is 24. That is again 1 by R is equal to, we want to take the LCM of these 4, 8, 12 and 24. How to find it? You know how to find the LCM of this? How we can find? That means 4, 8, then 12, 24. With the 2, 4, here 6, 12. Again with the 2. 1, 2, 3, 6. Again with the 2. 2. That is 1. Here 1. 3. Here 2 times 3. Again with the 3. 1, 1. Now see 2 into 2, 4. 4 into 2, 8. 8 times 3, 24. Now the LCM of this R is 24. Now after taking LCM, we want multiply each fraction with the LCM that we got. That means 1 by 4 into 24, how much it will be? That means 1 by 4 into 24. How many times? 6 plus 1 by 8 into 24. How much? Is 3. Then 1 by 12 into 24. That is 2. Then 1 by 24 into 24, that is equal to 1. That is 1 by R is equal to 6 plus 3, 9. 9 plus 2, 11, 12. This is 12 by 24. Now we can take a reciprocal. That is R equal to 24 by 12. Here reciprocal is R by 1, but by dividing with 1 there is no change. Hence we here only taking R. That is 24 by 12. That is equal to how much? It is 2 ohm. It is how much? 2 ohm is the resistance in the circuit. Now this is the least resistance that is getting in the circuit. Okay. Now these are the questions here given. Now we can discuss about heating effect of electric current. First of all, we want to know what is the source of electrical energy. Battery and cell. These are the sources of electrical energy. That means some other sources also, generator, dynamo. These are all sources of electrical energy. Here we are discussing about electrical energy sources as a battery and a cell. Now, how this battery or cell produce electrical energy? How this battery or cell produce electrical energy? See, within the cell, there will take place some chemical reaction. Within the cell, that means inside the cell, there will take place some chemical reaction. What will take place? Some chemical reaction, or otherwise, chemical energy within the cell converted into electrical energy, and that produce potential difference. That means within the cell there is a chemical reaction. So the chemical energy in the cell converted into electrical energy, and it provide a potential difference. potential difference created by this chemical action. Now, how this electrical energy flows? How this electrical energy flows in a circuit? We know by the reaction within the cell or the change of chemical energy, what happens? There will produce a potential difference. That potential difference maintains actually the flow of electrons. That means this potential difference creates the movement of electron within the circuit. That means when the electrons move through the circuit, that produces a current. But it produces a current. So, source of electrical energy, battery or cell, how electrical energy produced by the chemical reaction within the cell and a potential difference is developed. How electric current flows in the circuit means this potential difference create the movement of electrons within the conductor and that produce the flow of current. That produce the flow of current through the circuit. Now we want to know is the energy supplied by the cell is completely used to do work or some other part or a part of it is used for some other purpose. When the electric current flows through the circuit, a part of it is used for, a part of the electric current is used for doing some useful work. A part of electrical energy is used for doing useful work. Then what happens to the remaining part of the electrical energy? That means when electric current flows through a circuit, a part of it is used for doing some useful work. Then what happens to the remaining part? That remaining part is changed or converted into heat. That is, the remaining part is converted into heat. We know what is when a fan works continuously. There produced heat. By touching it we can find out its temperature is increased. That means when an electric appliance works continuously, there will produce a certain amount of heat and its temperature also rising. Now suppose the circuit we use is purely resistive. Suppose the circuit that we use is purely resistive. Then what happens to the electrical energy we supply? If the circuit is purely resistive, the given energy completely converted into heat energy. That means the given electrical energy completely converted into heat energy, and that is called the heating effect of electric current. What is actually heating effect of electric current? If the circuit is purely resistive, the electrical energy given to it is used for converting as a heat, and that is called the heating effect of electric current. That is called heating effect of electric current. Now see, under a potential difference of V volt, a current of I flows. Under a potential difference of V volt, a current of I flows through the circuit in a time t. Then the charge flows through the circuit is Q. What are the things? Under a potential difference of V, current through the circuit is I, the charge flowing through the circuit Q in time t, then the amount of work done in the circuit W is equal to, we can take as VQ. The amount of work done is equal to W is equal to V into Q. The amount of work done W is equal to VQ. The amount of work done W is equal to VQ. Okay? If the work done we got as this one, and also we know I is equal to what? Q by T. That means charge flowing unit time is called current. Charge flowing in unit time is called current. So the electric power in the circuit P is equal to, that means work done this W we can take as what is W is also equal to P into T. That means work done PQ and W is also equal to what is P into T. And here this P is equal to, we know power in unit, power is the power P is equal to VI, that is work in unit time. So W is equal to, we can take as VIT. W is equal to VIT. W is equal to VIT is the work done, and this work is actually here becomes as a heat, so H is equal to VIT. Here the work done W is equal to P into T, and also W is equal to VIT because P is equal to VI, and H is equal to, this work is here, that means work done here is using as a heat, so H is equal to VIT. H is equal to VIT. By applying Ohm's law, we know V is equal to what is actually IR. By applying Ohm's law, this heat H is equal to, by applying Ohm's law, this heat H is equal to what is, instead of that is V, we can write as IR. So this V we replace IR. So this relation become what is I square RT. This relation, that means heat producing, becomes what is H is equal to I square RT. This relation is called actually Joule's law of heating. This relation is actually called Joule's law of heating. That is H is equal to I square RT. That means current through a resistor and potential difference V volt we can measure, and an ammeter to measure current, battery and switch. These are the devices. From this we can measure the current. That means from this we can measure the current I. So we can get the relation H is equal to I square RT. This is actually Joule's law of heating. What is actually Joule's law of heating says heat produced in a current carrying conductor is equal to the product of the square of the current, and resistance, product of the square of the current and resistance, and time in which current flows. So H is equal to I square RT. From this relation we can find out how much heat is producing in the circuit. So H is equal to how much? I square RT is the relation which shows Joule's law of heating. Okay. Now see, we discussed about series and parallel connections relations to solve our numerical problems. What is the relation we got? One of the relation is R is equal to R1 plus R2 plus R3 for series connection, and for parallel connection it was 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Then we solved numerical problems relating to these equations. Then we discuss about heating effect of electric current. we discussed about the heating effect of electric current, which is the heating effect of electric current shows heat produced in a current carrying conductor. That means heat produced in a current carrying resistor is directly proportional to the product of square of the current, resistance and time in which current flows. From these relations you should remember these relations. What is V is the potential difference, I current, T time, Q charge. From this work done we can write as V into Q. That means work done to flow a charge Q under a potential V is W is equal to VQ. That is work done to flow a charge Q under a potential V is W is equal to VQ, or it is also equal to W is equal to P into T. Here P is actually what is VI. Then this work is actually here heat producing, so it is equal to, we can write as VIT. This circuit, from this circuit we can find a current, that is current through the resistor, and with this all from this current we get the relation H is equal to I square RT. Then with this all we can wind up today's class.